All right, guys, today we want to talk about feedback reactions. All right, now remember from the last couple of days, we've been talking about things staying in equilibrium, right? When we talk about like osmosis, so when we talk about osmosis and we talk about diffusion, right, and how solutes and water move from one location to another, that's because my cells, right, cells are trying to reach equilibrium. And then, let's spell equilibrium, right? When we try to reach equilibrium, and then by reaching equilibrium, I'm trying to maintain homeostasis. Gosh dang it, I'm trying to reach homeostasis. Okay, but that's at a cellular level. And so now my entire idea for today is that I want to reach homeostasis within an organismal, or we could even do earth level ideas. Okay, so instead of my cells being in homeostasis, I want to get my entire organism to be homeostasis, which is going to be a lot of moving parts. I have two different types. I have one that's called negative feedback. And then my other one is, guess what, called positive feedback. So let's talk about negative feedback first. Okay, let's talk about negative. Let's do this pretty color. Let's talk about negative feedback first. Negative. All right, so negative feedback, my entire goal is to maintain homeostasis by, let's do regulating a set point. Okay, now a set point, this is going to be the ideal conditions, which is kind of a funky definition, but the idea is actually really simple. So let's take this person right here. Okay, here's my person. Look how happy he is. All right, normally a person's body temperature is what? Okay, around 98 degrees. Okay, so here's my person. He's happy at 98 degrees. What happens when you guys get too hot? What does your body do? Well, when your body gets too hot, that means you start to sweat. All right, well, what does sweating do? Sweating cools your body off to back to that 98 degrees. All right, what happens when you guys get too cold? That means you start to shiver. And what does shivering do? Shiver makes your muscles contract back and forth really rapidly, creates a lot of heat. That heat raises your body temperature back up. So this is a negative feedback because this right here, this 98 degrees, this is my set point. And so then my body is just trying to regulate around my set point. If I get too hot, I sweat. If I get too cold, I shiver. That's one example. See, very simple. My other example, let's talk about sugar levels, right? So let's talk about blood glucose. All right, blood glucose levels, like the regular, I know that's not something a lot of us know, but our regular blood glucose level is around 90, okay? We'll say 90 units. Do we really care what the units are? No, not today, because this is just us understanding a whole concept. So here's your guys' blood glucose level at 90 units. Now, what happens when you guys start to eat? Okay, when you guys eat, what happens to your blood sugar level? All right, well, your blood sugar level, this starts to get high. So now blood sugar is high. Well, can your guys' blood sugar stay high forever? No, that's really, really bad for you because that can cause you to go into seizures. That can cause death, right? And so what my body needs to do is he needs to get my blood sugar to go back down. Well, you guys should kind of know how we get our blood sugar to go back down. If you may not know you know this, but you do. So when my blood sugar gets too high, to drop my blood sugar down, this is when I start to secrete insulin. And we've heard of insulin before. Say diabetics need insulin, but that's because they can't regulate their blood sugar. And how insulin works, it's actually pretty cool. Here, I'll put it over to the side. So here's your guys' bloodstream, right? And then this is all of the glucose inside. So this is glucose, and this is a lot of glucose. But butting up against your bloodstream are, guess what? Cells. And so then when I add insulin into this, insulin. So insulin, what he does is that he tells the cells, hey guys, there's too much blood sugar in my circulatory system, and the cells need to take it up. And so now all of this blood sugar, right, or all of this sugar starts to fill in my cells. And now that he starts to fill in my cells, guess what? That's going to lower the sugar in my bloodstream, right? So I can either store it inside my cells, or from the first unit, we learned that we store glucose. Well, let's spell glucose, right? We can store glucose as glycogen in the liver. And so that's really what's happening. When you guys eat and you have too much blood sugar, it gets too high. Well, too high is dangerous. So then I secrete insulin. Insulin increases the absorption of sugar in my cells, and then I can further store it as glycogen in my liver, which is going to bring my blood sugar back down. But what happens if you guys don't eat for a while, right? So what if you don't eat? That means my blood sugar goes low. Blood sugar gets low. Well, when your blood sugar gets too low, guess what? You guys can go into a coma and you can die. But when you guys don't eat for a couple of hours, we're all not just dropping dead. That's because when my blood sugar gets too low, then I tell another hormone, a lot of this is hormone based. I tell the hormone to, hey, that we need to take that glycogen and convert it back into glucose, which is released inside my bloodstream. And then when I release that glucose back into my bloodstream, then I get my blood sugar back to normal levels. So this right here, this is my set point. And so if you guys notice, if you look at the temperature, if you look at your blood sugar, how negative feedback works, it always looks like a figure 8, right? Where the middle of this is where my set point is. And then I just try to regulate to get it back to that normal spot again. All right, so now let's talk about positive feedback. Positive feedback, okay? Now, positive feedback, how this works is I'm trying to amplify my signal until the set point is reached. Okay. And this one is kind of, and it's easy to understand. So let's do one example. Let's talk about this person right here. So here's my person. Look how happy they are. But oh, look at this. They're pregnant with a baby. And so now what I want to do is I want this person to have the baby. And so how does labor start? Well, it starts by contractions. Okay? And so this cute little thing, this thing is going to start contracting, right? So walls of the uterus, they start to contract. They kind of start to push in. And so whenever I start contractions, guess what? That is going to force, so here's my cute little baby. That's going to force that baby to push down on the woman's cervix. Well, when I push down on the cervix, that's going to send all sorts of hormone signals to my uterus. It's going to send all sorts of hormone signals to my uterus to do more contractions. And then the more contractions I do, the further down he pushes on the cervix. And so you guys have all heard about how contractions, how they start out just, like like really far apart, but then closer to the person having the baby, those contractions get closer and closer and closer together. That's an amplification of the signal, because then my set point, my normal point, would be having the baby, right? But they're all related on each other, because when this guy pushes down on the cervix, right? So here's my baby, he pushes down on the cervix, that sends a signal up here to do more contractions. Well, the more contractions I have, the more he pushes down, and so that signal just keeps going and going until I have that baby, which is the set point. Or another example would be if you get a cut. So look, here's your arm, and look, you guys just cut your arm, and so now it's bleeding. But you guys have gotten a cut before, and you don't bleed out. So what happens is, so here's my open wound. So this is a big picture of it. Here's my open wound, and you guys know that you have your circulatory system, right, running through. And inside your circulatory system, you have these little guys right here. These are called blood clotting factors. And what they do is that they help clot a wound. They help seal up a wound. And so as this guy is rolling through my circulatory system, because they don't travel in gangs, they just travel, at will. But when he gets here and he sees that there's an open wound, he's like, oh my gosh, there's an open wound here. And so then he calls his buddies. Well, when he calls his buddies, so here's my open wound, and he's like, hey, you got to come over here. So here's now a couple of his friends, right? And then when their friends get there, they're like, oh my gosh, there's an open wound here. And so then they call their buddies. And then they just continue to do this. So here's my open wound. And now there's even more of them, right? And they're all like, oh my gosh, there's an open wound here. And so then they call their buddies. And that just keeps happening over and over and over again. That just keeps happening over and over and over again until this wound is completely full of the blood clotting factors, and then you're not bleeding anymore. So you not bleeding is the set point. It's the normal point. Okay, so feedback is just us trying to regulate our system. Let's go ahead and add this over here. Mostly by regulation. These are hormones that are doing all of this talking back and forth. You have the two types, negative. Negative, his entire job is to regulate the set point. This is what I see most often inside body systems, and so temperature and blood sugar are really good examples. And then positive, I'm amplifying until I get to that set point. And so that's a person having a baby, and then you guys closing up wounds. All right, I hope that helps.